Hello and welcome to Unit 1, Lesson 1 of Algebra. So number sets and their properties. Natural numbers start with the number 1 and they count up. Whole numbers, I think of donut hole, which is 0, starts at 0 and they count up from there. So the natural numbers are all contained inside the whole numbers. The whole numbers are all in the integers, so the integers are the whole numbers and their opposites. So say -2, -1, 0, 1, 2, and they continue. All of these sets are in the rational numbers, but rational numbers also include decimals that end, like 0.5, any number that can be put in the form of a fraction, say 3/8, and any square root that is perfect. So the square root of 25 is 5. So we know that's rational because it's in the natural numbers and the whole numbers and the integers. The rational numbers are everything. They're the opposite of rational numbers. So decimals that go on forever and never repeat. So say 0.3216 and the dot means it goes on. Any number with pi in it is irrational, and also any square root that is not perfect, say the square root of 29. And all of these are real numbers. Here's another picture for you to look at. So some examples. 15. Where did we find that up here? 15 was a natural number. It's a whole number. It's also an integer, and it's rational. So there it can be in multiple sets. So we said natural, whole, it's an integer, and it was rational. -6, on the other hand, is not natural, it's not whole, but it's an integer and it's rational. Decimals, we found those in rational numbers. Fractions were in the rational numbers. Remember, any number with pi in it was irrational. Any square root that's not perfect, also irrational. Number 7, this has a bar over it. If we remember from last year and maybe the year before, that just means that number repeats. So repeating decimals are rational. Again, any number that can be put in the form of a fraction, also rational. Properties. For each group of examples, determine which property of real numbers is being demonstrated. So right here we have 219, 219. When order stays the same, but the parentheses move, that is the associative property. Number 2, 7 times 5 equals 5 times 7. When the order flip-flops, that is the commutative property. Oops. Let's go back to this. What's going on here? Let's go back to my drawing. Number 3, 8 times 27 is the same as 8 times 20 plus 8 times 7, which we might know from the second example better, 9 times x and 9 times 6. That is the distributive property. Number 4, 875, 875. Once again, it's the same order, but the parentheses moved. That was associative. And lastly, 3 plus 8 plus 10 plus 7 is the same as 10 plus 7 plus 3 plus 8. So once again, it was flip-flopped. Look at the second example. 7 plus 9 equals 9 plus 7. That is commutative property. So I hope you found this as a review from last year and a good refresher. Make sure you look back at this to complete the homework. So I hope you enjoyed it. Have a good day.